Now that we've defined what a set is, we need to be able to count objects in a set and use our knowledge of sets to help us to do that more efficiently. So a few definitions you need to be familiar with. If A and B are two sets, then A and B, or the intersection of A and B, is the set of elements that's common to both sets. A or B, the union of A and B, is the set of elements that belong in both A and B. So in Venn diagram form, it's shown this way. The sliver where the circles overlap is the intersection, or A and B. The entire circles are the union of A and B, A or B. If the intersection of A and B is the null set, then that means there are no elements in common in between either set, and they're called disjoint sets. The Venn diagram would look like this. Okay. In this example, since A and B have no elements in common, they are said to be disjoint sets, as we said above. So given these two sets here, we want to find the intersection and then the union. So for the intersection, we are looking for the elements that are the same in both. So if I start highlighting the ones that are the same in both, I notice that I've got a 3 in both sets, a 5 in both sets, and a 7. So that means that my intersection is going to be those 3 numbers. Now my union is going to be larger. That is the one where I have elements that are in either A or B or both. So that means that I have all my numbers, so 1, 2, 3, 4, 5, 6, 7, 9, and 11. An element only appears once when it's written in a set. So for example, in the union of A and B, 3, 5, and 7 are in both A and B, but we only write them once when we're listing all the elements. Based on the information that we have above, we can define the additive principle. So this is A or B is equal to the number of elements in A plus the number of elements in B, take away the number of elements that are in the intersection. So from our example above, we have 7 elements in set A, 5 elements in set B, and then 3 elements that are in the intersection, which gives us a total of 9 elements in our union, and we can count those above if we go back up here. 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So now we're going to look at some examples here. We've got 3 sets, R, S, and T, and we're going to find some information above. So the first one we're looking for is S and T, so the elements that are in common between S and T. There are only 2, 10 and 20. Then we're going to look for the union of S and T. I'm going to write this one down below because there's more elements. So we've got 5, 10, 15, 20, 25, 30, and 40. So that's all the elements that are in S or T or both. C is the number of elements in set S, so that's going to be 5. D is the number of elements that are in the intersection between S and T, which is the number of elements in our set from question A, which is 2. E, we're listing the elements in the union of R and T. So again, I'm going to go down below because we've got a lot here. 10, 20, 30, 35, 40, and 45. So the elements that are in R or T or both. F, we have the elements that are in common between set R and set S. That is our null set. There are no elements in common. G, we're looking for the elements that are in T prime. So those are the numbers that are in R and S, but aren't in T. So we've got 5, 15, 25, 30, 40, and 45. And then the last one, we've got the elements that aren't in R and aren't in T. So for H, I'm going to draw a Venn diagram. So here, I've got R and T, and then outside of that, I'm going to have my elements that are in S. So the ones that I have in R and T are 30 and 40, so I'm going to put those in the intersection. Left over in set R that aren't in T are 35 and 45. In T that aren't in R is 10 and 20. And then my leftovers in set S are 5, 15, and 25. So from my Venn diagram, the ones that I'm looking for are not in R and not in T. So that means I'm only looking for the ones that are outside of the circle, which is going to be the elements that are in set S that aren't in R or T. Those elements are 5, 15, and 25. You could draw a Venn diagram for the rest of the questions, depending on how easy it is for you to pick out the commonalities between the sets. The last example that we're going to do here is to set up a Venn diagram, and we're going to answer the following questions. So here gives you the information about the Venn diagram. So I know that the total in my universe, or my universal set, is 54 people. In this circle are going to be the people that vacation in Eastern Canada, Western Canada, and then Central Canada. Now, in order to figure this out, I'm going to start at the innermost region. So I know that 4 people vacationed in all 3 regions. Then I'm going to gradually build out from there. So in this region that I've highlighted in red, that represents the total number of people that traveled to Western and Eastern Canada and all 3. So if I look at my Eastern and Western Canada here, I know that the total of those 2 sections has to be 11. So in this little segment here, I would have 11 minus 4 would be 7 people went to Western and Eastern Canada, but not Central Canada. I'm going to repeat the same process for the 2 other segments here. So I'm going to highlight this next one in yellow. This is Eastern Canada and Central Canada. I know that those 2 segments have to add up to 10. So I would have 10 take away 4 equals 6 here. And then my last one I'm going to do in green. So this last overlap is going to be the people that vacationed in Western Canada and Central Canada only, but not in Eastern Canada. So I know that that is 17. So I would have 17 minus 4 would be 13 people in that section of the Venn diagram. So now we're opening it up. Now we're going to do the full circle. And let's start with Eastern Canada here. So the part that I'm circling now, those are all the people that vacation in Eastern Canada. So 7 plus 4 plus 6 plus this extra bit here all has to add up to 28. So I can start with 28, and I'm going to take away the sum of those other 3 sections. So that gives me 11 people that only vacationed in Eastern Canada, which is actually the answer to my first question here. Okay, let's do our next one. Okay, now I've got a purple. So now we're looking for Western Canada. So this whole part of the circle, Western Canada, has to add up to 25. So just like I did, I can start with 25, and then I'm going to take away the sum of the other 3 sections of that Western circle. So take away 13 plus 4 plus 7, which is going to give me 1 person that only vacationed in Western Canada. And then my last one here, change it to, let's see, I don't think I've done orange yet. So I've got this whole circle here is going to be my Central Canada, which is 31. So I'm going to start with 31 and then take away the sum of the other 3 sections of that Central Canada circle. So I would have 8 people that only vacationed in central Canada. Now the other thing that I need is going to be the number of people that went on no vacation at all. So no vacation, I would have 4 people left over. In order to figure that out, I can start with 54, and I'm going to take away the sum of all of those inside parts of the circle. So take away 1 plus 7 plus 4 plus 13 plus 11 plus 6 plus 8, and that's going to give me 4 people that didn't go on vacation, okay, which would be 4. That means that the number of people that vacationed in at least one of these regions, so this would be the total in the circles, which is what I calculated to find the last part of my Venn diagram, are going to be 50 people. So 50 people went on vacation in at least one region, and then 4 did not vacation at all.